Hi, and welcome back to another video. So over the past few years working on solar systems, one of the things that we've come to realize that some homes have really got bad electrical, wiring or electrical systems. And if I say bad, yes, some are that bad. And this is as a result of sometimes not hiring qualified personnel to take care of their electrical systems, some not having, good supervision, among others. And these things are part of the things that contributes to fire outbreaks in homes that it's really a problem, because you don't want to build your house, spend a lot of money, and then all of a sudden you have it come down as a result of fire, and this cause of fire is as a result of poorly done electrical work. So the purpose of this video is to just take you through some basic electricals or electrical works that or some things you can look out for, especially if you're hiring an electrician to take care of your electrical works for you. So without not talking further, let's just go ahead and get into the video. So before we start, I've got quite a number of items on my desk over here. So this is a distribution board. This is a single phase distribution board. There's a TPN or a changeover. We have a hydraulic press machine or two. We have different size of cables over here. We have conduit pipes over here, as well as we have conduit boxes here. We have ferrules, and then we have cable connectors or cable lock also here. Just as I said, some of the things that causes electrical fires is as a result of poorly done electrical works. So if you look on my desk over here, you see different sizes of cables here. So we have a 1.5 mm square cable, we have 2.5 mm, we have 4 mm, we have 10 mm, we have 16 mm. So you may ask, what are the purpose of some these cables? So I'll give you some examples of in what cases or scenarios you may be using some of this cables. So talking about a 1.5, you even notice that among all the cables that are here, there are different colors. So let's start with the colors. There's red and black and green and yellow. Those are basically the colors that we have over here. Now you may ask, what is the purpose of these colors? These colors have what they mean or what they do. If you have your electrical works done and somebody comes, or a qualified electrician comes by and opens up your distribution board and sees the color code, it communicates something to the person that, okay, black simply means it's for neutral, red is for live, green is for earthing system. So then it's easier to do whatever the person has to do in terms of either tracing a fault or something. But if you come and these are not conformed or not followed and they are done anyhow, it creates a problem. So aside black and red, there's also blue, and then there's also brown. Blue would maybe also go for the black, which is a neutral cable, and then the brown can also go for the red, which is the live, and then you have green or yellow, which represents the earthing system. Now when you look at this cable, which is a 1.5 mm cable against the 2.5, 4 mm, 10 mm, and then 16 mm, you notice that these cables have different sizes. Hence the reason why they are for different kind of job. So a typical 1.5 mm cable will be for your lighting system and even sometimes your fan system. So you have your lights, you have your fans, then you are looking for this size of cable because they don't, the power that they carry is a bit small, and they are able to cater for those appliances or those equipment. Then you have a 2.5 mm cable, which is usually for your socket system. So you have your socket for your TVs, your fans, your fridges, among others. 2.5 mm is basically used for those kind of works. So then you're able to have the correct size of power that is going to go through these cables. Then you have a 4 mm. 4 mm usually will be for like a cooker unit, as well as your microwave, maybe kettle, heaters, among others. Then you're looking at this kind of cable size. Then you have 16 and 10 mm. Even before 10 mm, you're looking at 6 mm. 6 mm can also do works, such as your cooker units, because there are some cooker units that have specific ratings of or size of cables that are required to be used. So you can have 6 mm take care of such systems or appliances, either heaters, cooker units, among others. Then you have 10 mm and then 16 mm. Now let me start off with 16 mm. So if you have, for instance, power coming from the electricity company, where they terminate power at their or at the meter, then you are looking at 16 mm, which is connecting or tapping from that power that they've terminated over there into your distribution board, which we have over here. So 16 mm usually will take care of that. So this is like a main cable which is going to be distributing power to all these sizes of cables. So the amount of power this cable will carry is more than what this will carry. It's more than what this and this and this will carry, and it goes like that. So that is where you have a cable like such as 16 mm cable, which is used for such jobs. And a 10 mm cable also carrying power from this and then also distributing it to other appliances or other load. So this is just a basic understanding of these cables and their purposes and what they do. Now you may ask, how do I tell that this is a 1.5, this is 2. Because if you look closely, the difference is not so wide. Yeah, unless you get to the very big ones and you compare them to the small ones, you notice that the difference is wide. But one way you can tell what size of cable this is when you read it. When you look closely, they have some small inscriptions on it. When you look, let me see, I don't know if the camera can get this. I'm sure you might struggle, but if you read the ratings or the numbers or letters or whatever is written on it, you'll be able to tell that, okay, this has 1.5 mm square written on it, this has 2.5, this has 4 mm, 10 mm, 16 mm, among others. Now, aside knowing the size of cables by reading from what is written on the cable, sometimes even on the coil that's written on it, aside that also, you have to also look at the quality of cable, because there are quite a number of inferior, products on the market, and to prevent house fires, it's very important to go in for quality cables which is not going to cause any challenges or issues with your electrical system. So I can't recommend any product, but of course, if you have a good electrician or electrical engineer, you should be able to tell what kind of brands you should be looking at. So yes, that's basic concept of the cables. And then what you may ask, what is the purpose of cable? So the cable is basically to transfer or take power from one point and distribute it to another point. So in this case, if we are looking at this as our meter or main distribution board or whatever it is, we are having cables coming from the distribution power company to our meter, and then the cables will take the power from there and then distribute it to our distribution board, and then from our distribution board to our lights, our fans, among others. So those are the basic purposes of these cables, and their sizes performing different roles or different functions. Now after that, then we look at the distribution board. So this is a single phase 8-way distribution board. However, it has provision for 2 additional breakers, making a total of 10-way, but ideally it is 8-way. You may ask, what is this way, what is this single phase and the rest? So in our part of the world, we use either a single phase or a 3-phase system. So if you use a single phase system, it means your distribution board is going to be a single phase distribution board with different ways. The ways is basically the number of breakers that you can fit in that particular distribution board. So you have a single phase, maybe 8-way, single phase, 6-way, 8-way, a whole lot. Yes, that means that those are the number of breakers you can fit in. Then you have a 3-phase, maybe. So once it is 3-phase, then it should tell you that whatever quantity you have, you are going to multiply by 3. So if you have a 3-phase 8-way, it means you have 24 slots because it's 3-phase. Because you have, with 3-phase, you have different power lines coming in. So you have 3 live lines and then 1 neutral line. And with single phase, you have just 1 neutral line and then 1 live line. So that's the difference between a 3-phase and then a single phase. So let me just go over again. A single phase will have 1 live line and then 1 neutral line. And then a 3-phase will have 3 live lines and then 1 neutral line. So if it's a single phase, it means you have just single units. You have your power lines coming in, your neutral line, with then distributing it for the various breakers, and then those breakers are going to serve the various appliances that you have in your house. And if it's a 3-phase, you have 3 of whatever ways you have. So if it is 8-way, 8 times 3. If it is 12-way, 12 times 3. It means that you are going to have a bigger size panel, which will have a lot of breakers in it, and then each for each line, that is the 3 live lines that you have each line having its dedicated breakers, among others. So that is just a basic concept of what they mean or what is meant by a single phase, a three-phase system. Now you may ask, in what circumstance can you tell whether I need a three-phase or I need a single phase? Now that is going to be decided by maybe your electrical engineer who is working on your project, because usually this is based on the load you have within the house. A typical 2-bedroom which hasn't got a lot of load would need something like this. This is a single phase 8-way, but a bigger house which has a lot of rooms, which has a lot of air conditioners, among others, we need like a 3-phase. It could be a 12-way, it could be an 8-way, among others. Those will be determined by your electrical engineer working on your project. Now if you look at these breakers, you notice that there's this main one here. This is an MCB, or main circuit breaker, and then you have this smaller breakers. Now these smaller breakers also has got ratings. I don't know if you look at it closely, you see the ratings. So you have this having 6, even starting off with this is 100 amps, this is 6 amps, this is 6 amps, this is 10, this is 16, 20, 32, and then also 32 amps. Now these sizes of breakers are for different kind of appliances or different kind of circuits. So with 6 amps is usually would be for your lighting system, such as your lights, your spotlights, your LED lights, among others, and then also for your fans. So you can have 10 for your fans, you can have 6 for a light, or you can do any of this. That is what this purpose these breakers are usually for. That is for your electrical system in your house. Then you have 16 mm typically for socket. Yes, you can also have 20 mm for socket, especially when the circuits are more. Then you have 32 mm maybe for your cooker units, for air conditioners, among others. Now there are other sizes of breakers, bigger ones that are also for other purposes. But for this particular distribution, well, these are the breakers that are fitting here. Now these breakers can be removed, taken out, and then replaced with other breakers in case they are faulty. And you may ask, what is the purpose of these breakers or circuit breakers? They are a level of safety that you have as part of your electrical system, so that in case something goes wrong, they trip to go off, or basically trip to go off when they are in their own position, so that there isn't problem with or it doesn't end up causing fires or challenges with, or even damaging your electrical units that you are using. That is one basic purpose of these circuit breakers, depending on the sizes. So in this case, if you have an electrician who is carrying out a job for you, it is very important that the electrician is doing or using the right size of breakers for the respective job that is supposed to be done. You don't want a situation whereby the electrician is using 20 amps for light. That is too much. You get it. You don't want a situation where you're using 32 amps for socket, although it can be done in such cases, unless there are some unique cases where maybe you may perform that. But ideally, this is what has to be done: 16 mm for a socket. In some situations or cases, you can have 20 amps, and then 32 amps maybe for air conditioner systems, among others. So that is basic understanding. So for this particular panel or distribution board, if you look closely, there are different things in there. So there's a bus bar, this is the neutral bus bar, it's written in there. This is the earth bus bar, it's also written here. And then the live is distributed using this bus bar, also that is distributing the power. So you have your power lines. If you look at this breaker, it says 1, 2, 3, 4. You have your power line coming into the 1, coming out from 2, and it's being distributed for all these breakers. Then you have your neutral line coming into 3, and then taken out from 4, and then distributed to the neutral bus bar, which is, if you look here, there's a big spot here for bigger size of cable. So like a 10 mm or 16 mm or 6 mm, yeah, among others. Then you have these smaller sizes which are going to go to each breaker over here, depending on the size that you're doing. So for 6 amps, you have a 1.5 mm coming. For 10 amps, or maybe 1.5. For 16 amps, you have 2.5. For 32 amps, 20 amps, 32 amps, and we can have 4 mm doing that. So that is a basic just understanding of the distribution board. Aside that, also you notice that this distribution board comes with labels that are meant for you to label each circuit. Now each circuit may represent a room, each circuit may represent a space within your house. So if you have like your living room, you can have your label. So this is the cover that goes on top of this. So you can have your label that is going to go, maybe this particular breaker is for living room, this is for kitchen, this is for bedroom, among others. Now aside that, also the labels here may represent socket. So if you look closely, there's receptacle, there's lighting, there's air conditioners, among others. Now it is important that a proper electrical system may have labels. You may not necessarily use these labels, but you can use a marker to indicate on each circuit breaker where the breaker is going to, so that in case there's a challenge in the home and even you, the owner, is around or somebody is around, you may have to easily, identify that, okay, this is the breaker causing the problem. Maybe you have to turn it off, you have to turn it on, maybe if it's stripped, among others. So that's one important thing that it's very important for your electrician to do, aside doing using the proper size of cables, using quality cables. Also look at the labeling of these various circuits, so that it's easier to identify challenges even if you are not a professional in that space. Aside that, also it is also important for them to terminate the cable neatly within the panel. You shouldn't overcrowd this panel with so many cables. That is why there are different sizes of panels or different sizes of distribution board for each work. So have the right size of distribution board to be able to distribute your cables evenly in them and not necessarily overcrowded, because sometimes overcrowded wires also end up causing problems. Yeah, so that is just a basic explanation or basic overview about the distribution board. Now let's look at these boxes. So these are conduit boxes. This is a 3x6 conduit box, and this is basically 110 conduit box. So I think this is a 2x4. So yeah, 2x4 conduit box. Yeah, that is a 110 system, and this is for a 220 system. So you may ask, what is 110 system, what is 220 system? So usually in some parts of, or in other parts of the world aside Ghana, such as in the US, where they have like a 110 system, in Ghana we have a 220 system. So you have somebody come from the US and says, okay, I want to have both 110 and 220 system. So then you are going to be using this conduit box for 220 and this for 110. I've seen instances where people use this for both, and it creates a lot of problems. Yes, because it's no, you can't use it. You can't use this for both. However, it ends up creating problems because then the size of sockets you have for this is going to be the same size you have for the 110 system if you are using this conduit box for both. But if you are distinguishing it and using this kind of conduit box for the 110 system and this for 220, it's easier to identify that this is for 110 and this is for 220. So if you are having an electrician do a 110 system as well as a 220 system for you, please insist that they use the right type of cables, because these have purposely been made for 110 system and this for 220 system. Now aside that, this is a plastic type. There are metallic types as well. Some metallic types do rust, so if you are getting a metallic one, make sure it is not a rusty type. And then some plastic type also do not have proper thread in here to be able to hold the screws. So make sure you are getting the right type of conduit box which is going to be used. Now, talking about this 220 and 110, I have seen instances where this distribution board is used for both, which is not really right. If you're having different type of system, being a 110 and 220, it is important to have different distribution boards serving each of them. And the reason is because when there are faults or challenges or problems, it's easier to trace, isolate, identify, and then rectify them, as against using one distribution board. Recently I went to see a house where they had 220 and 120 system, and this was the conduit box, and you can imagine how they are scattered all the sockets all around. It was even difficult to tell which was 110, which was 220. And aside that, also the electrician used one distribution board for that and says you can divide it. His reason was to save cost, but there are certain compromises that are not worth it. Imagine you plug in a unit in a 220 system, whereas it is a 120, it's a 110 appliance. You are just basically going to damage the appliance. So it is very important to pay attention to some of these things when these works are being done for you. Now, these cables do go through a conduit pipe, either this pipe or this hose over here. Don't have an electrician run your cables just on top of your ceiling like that without going through either a conduit hose or conduit pipe. These sometimes end up creating issues because you can have a mouse in there, go through some cables, and eventually it touches each other and then ends up causing fire. So make sure that whenever cables are going to be passed, they are going to be passed in either a pipe or a hose, and these pipes usually will go into a wall or can also go into a ceiling, and this will usually go into a ceiling, but you can also have this go into the ceiling as well. So whenever your wiring is being done, try as much as possible to insist that it is being passed in a conduit pipe or a conduit hose, so that you don't end up having issues. And even if they are done, it is easier to remove or pass cable through this as against just leaving the cable haphazardly on the ceiling. So that is one thing you also need to pay attention to when you have an electrician or an electrical engineer, take care of your electrical works for you. Then let's talk about this TPN. So this TPN, just as I said, a changeover, is usually meant to switch powers from different power source. So you can have a solar system, you can have a generator power source, you can also have the grid power source. So this is a 3-phase 200 amps TPN or changeover. So you have a slot for the grid, and then you can have slot for generator, and you can also have slot for a solar system. So this is how it works. You just close it, and then this would switch it, so that it switches it to different modes. Let me just, okay, because I have it on the table, it's not switching, but basically it switches it from one mode to the other using this particular pole, where it goes into this, it goes in here, and then it switches it from one mode to the other. And you can see it's 200 amps over there, even on the fuse that are in here, all 200 amps. So this is for like a big house or a big kind of job. There's 63 amps, there's 100 amps, among others. It is not your job to know what kind of amps you need for this kind of things. That is why you're hiring a qualified person to do that. But if you are asking the person a lot of questions, then you're able to tell whether whatever the size the person is using is appropriate or not. Now, the reason why I want to show you this TPN is that it has to do with its termination. If you look closely over here, this is a bolt and nut type of termination. And one thing I've seen with so many places that have this kind of TPN is that the termination, because they are electrical engineers or electricians, do not have the right tools. This is how they end up terminating the cable, putting it in here and putting the nut on top and basically tighten it. And I must say, this is really, really, really dangerous, and this is not even professional. That is why I have this crimpy tool over here and this cable lock over here. So let me just show you. There's always a tool or material for any kind of job. If you look at this cable lock over here, it is meant to go on top of a cable, be crimped together with a tool like this. This is a hydraulic tool, so that it doesn't go off. And that will usually go on top of something like this. Of course, this is not a size, there are different sizes, but that will go on something on top of like this. Then you have the nut coming with a washer on top of it to tighten it. Imagine or compare a termination done like this as against a termination like this, which is professional. And I see a lot of homes with the electricians doing this. So if you open your TPN and you've seen that the electrician has done this, please try and get him back to come and correct it, because this is one of the things that causes fires. Because in this case, you have loose contact, because look at how this is done. There's no way this is going to be as tight as this. In this case, you have a very loose contact over here. And imagine, this is the main power that is coming, either from a generator, either from your grid, either from your solar system. This is the main power that is coming in here before it is distributed to the distribution board. So if this is not properly done, what this does is that it causes it to have small sparks that comes around this, because heat is going to be generated. There's going to be small sparks causing heat to be generated, and this is going to cause the cable to burn. And once this catches fire, it can spread to other cables and eventually causing a lot of problem. And it's the same thing when the termination are also being done in your SPN or maybe your distribution board. In this case, if you don't have the cables properly terminated in either the breaker as well as in the bus bar, what happens is that whenever there's load, maybe more load, it starts causing sparks. You may not see it because this is closed, of course. And once these sparks happen, it causes the cable to melt, and over time it catches fire and it begins to spread, and then it causes your homes to burn down. Now, aside that, also one thing also it's important to point out is that these circuit breakers are for different circuit, just which we've mentioned. Now, you may ask, okay, if they are for different circuits, how many circuits can be on a specific breaker? So that is also to the electrician to determine that. But in most cases, for example, for socket, it is important not to have more than maybe 4 sockets on one circuit or one breaker. It would be ideal to have about 3 or 4 sockets just on one breaker, so terminated to one breaker, so that it doesn't cause overload. But if you have about 10, some places you go, you have about 10 sockets, about 8, 10, 12 sockets on just one breaker. That is not correct. So it is important to sometimes question your electrician, on some of these things. How many circuits are you going to have on this breaker? How many? Yes. So that you are able to understand that, okay, whatever they are going to do is proper. The same for the lighting system. Your instances where what people do is this, they just loop the cables, so the live cables and then the neutral cables to the various lights and fans, which is not proper. Ideally, for every house, maybe a room can have its own circuit breaker for the light. So maybe you have a couple of 2 or 3 or 4 lighting there with a fan. That is fine. But if you have overcrowded circuits, that is eventually also going to cause fire. So that is one thing that you need to pay attention to when your electrician is doing your electrical work. And then we have this material over here, which is known as ferrules. This ferrules is basically used to connect 2 cables together. So imagine you want to connect these 2 16mm cables. Because 16mm cables is usually hard in nature, it will be difficult to connect it together, although some people do it, which is not proper. That is why there are tools or materials like this. You twist the cables, or you take off the coating of the cable, you pass it in this material, and then you use your crimping tool to crimp it, and that is going to hold it very firm and tight, as against just putting the cables together. Now, this also comes in different sizes. This is 16mm, there's 35mm, there's different sizes, smaller sizes as well for smaller cable termination, among others. So in a nutshell, these are some basic things that you can pay attention to, especially the size of cables being used for the right type of work. And also, one thing I need to point out is that it is very terrible and very bad to combine different sizes of cables on a circuit. So imagine an example is you have 4mm coming, then you connect 2.5mm to that cable coming to the socket. No, that is not professional. Always have, if it is 4mm coming from the distribution board, 4mm is what is going to wherever it needs to go, being it a socket or whatever it is. If it is a 2.5mm coming, it has to be 2.5mm coming from the distribution board going straight to the socket. If it's 1.5mm, it has to be 1.5mm from the distribution board going. Of course, you can join cables. That is why you have tools or materials like this, but you don't have to join different size of cable. Imagine connecting 4mm to a 16mm. No, that is terrible. And those are some of the things that causes fire. So this is just a basic overview of some things you need to look out for, especially for electrical systems. So if you are in your house where the electrical job has already been done, just try to open your distribution board. It is not any difficult thing to do. If you can't do it by yourself, of course, get a qualified electrician. Let him come by, open it up. This thing is not going to shock you if you touch it. If it is properly terminated, it's not going to be an electric shock. Although it is metal, it has insulators around it, so it's not going to cause any shock. So you have your electrician come by, have him or her open it up, then go through it to see, okay, are the cables properly or nicely laid out in it? Are they is it overcrowded? Are the circuit breakers enough? Are they the right size of circuit breakers that needs to be done? Is the main MCB or main circuit breaker the right size of circuit breaker, among others, so that you don't wait to a long time, then you start having issues. And then also, it is important to know that if you have your electrical wiring down for certain kind of appliances, and maybe you're adding certain kind of appliances, maybe you have to relook at your electrical system so that you don't end up causing fire. So also, when you are getting an electrician for your electrical works, it is important to find out if he or she is a certified one. Yes. So electricians are supposed to be certified by the Ghana Energy Commissions before they can carry out any electrical job. So it is important to find out from that electrician if he or she is certified. And if he or she is certified, he should be able to show you his or her card that shows that he or she is certified. So there are certifications for domestic wiring. There are certifications also for commercial wiring as well as industrial wiring. So at least that said electrician should at least hold a domestic wiring certification that proves that he or she is capable of whatever electrical works that they are going to carry out. So that is also another important thing you need to know, especially if you are giving out your electrical job to someone. So this is just a basic overview of some of the things you can look out for, especially with your electrical system, because I'm pointing this out because, just as I said, during our period where we go to homes to have solar systems installed, sometimes some of the things that we see are bad. But among this, there are even many more that I'll be sharing with you in the coming time on some of the things that are not done right, and you can also identify them and then have them resolved as soon as possible. Yes, so that will just be about it for this video. I'm sure some part of it may be a bit technical, but just bear in me. I must say, this is a quick disclaimer, I'm not an electrical engineer, yes, but these are things I've learned over the years, especially in my role as a construction manager, managing building projects and the rest. So it's very important to understand these things so that when you have someone come to do any work for you, you have them do the right thing, because you don't want a case where you handle a project and then later there are problems. No. And if you know me, if I've ever done solar work for you, sometimes you notice that if there are challenges, we point them out, and if we can do something about it, we do that. Because one thing I've noticed that sometimes there may be problems with your existing system. You may be using it, may be fine. We will come in, install a solar system, then all of a sudden you start having issues. The reason is because some of these systems that we use are smart systems. So an example where at Tugbari, we had an issue with their phases, because the inverter is a smart inverter. If you interchange line 1 with line 2, it is going to notify you and it's going to create problems unless you rectify it. Yeah, so that is just something I need to say. I needed to point out so that at least something is done about it, so that some of these fires that we do have in homes and the rest will be a thing of the past. So that'll be just about it for this video. Thank you very much for watching. I'll see you in the next one.